Okay, today we're doing a demonstration in an AutoCAD program called Fusion 360, showing you how I go about 3D modeling an oil skimmer. Woo! So here's my work area in Fusion 360. You can see I'm starting with a gear motor and two pulleys. I'm now going to make the mounting plate. Using the move command that you see up there in the top of the toolbar or the ribbon. There, I'm moving it into place where I want it.
Wow.
And it's a good idea to save your work as you go. Great thing about Fusion 360, you can drag and drop parts from McMasterCard.com, so you don't have to 3D model every single nut, bolt, screw, washer, etc.
Wow.
So you can see this shaft. I went on McMasterCard's website and basically downloaded the 3D set file from McMasterCard.com, and there's my shaft for my pulley. And then I can manipulate it in Fusion 360. So then in the render mode, we can add paint colors. I'm going to paint the different components different colors so they stand out better on screen. You can see that hole there is where a set screw would go. Again, if you go up to that insert box, and that drop-down menu has a direct link to McMasterCard, takes you right to McMasterCard's website. You can type in the search box whatever part you're trying to find, nut, bolt, washer, pulley, etc. So I found that really helps speed up my workflow when I'm 3D modeling a product. You see, I add a retaining clip. I added a lock nut. Now I'm going to measure these holes and add some mounting bolts for that motor. And the hex bolts didn't work, so I'm going to use some cap head screws, some Allen bolts basically. Because it's tight tolerance on that motor mounting flange there. And the great thing, once I drag and drop in one bolt from McMasterCard's website, I can use the mirror command to make 3 more bolts, or I can use the copy command to make 3 more bolts. And here's a better view of the drop-down menu. So you can see here, I made a copy of it. I want to make a cover for this motor, so I simply hit the sketch command and made a sketch on the back of that mounting plate, drew a square, and then extruded the square out to the size I want. And I'm making another sketch on that plate that I just made, and I'll go up and use the extrude command on this to extrude it out to the size I want. You can see there's different options you have up here in the ribbon. The shell command is great. I'm going to use the shell command in a minute here to turn this solid 3D object into a shell, so it'll provide the cover for the motor.
Woo!
You can see I'm playing with the shell feature there. Or you can drill a hole if you want a round hole instead of a square hole. But in this application, I do need it to be square. It needs to be a cube that's hollow. And I want the walls to be 1/8 inch thick. And there you go. There's the cover.
Wow.
And then I'm going to make a flange, a mounting flange, that'll weld to that motor cover. And then the mounting flange itself is going to be what bolts to the mounting plate. And I want to add a weatherproof vent on the back of it. So I'm going to try some different size louvers, different vents from McMaster-Carr's website to see what fits good. So that way when it rains or they wash down the wash rack, you don't have to worry about getting water sprayed inside that electric gear motor. And you can see you can rotate objects 360 degrees, move them, up and down, left and right, get them where you want them, rotate them. I tried several different ones to see which one would work best. And later on in this demonstration, I'll show you where I add some holes to the bottom of this motor cover box, so that way the cooling fan on the motor will suck air in on the backside, and then the warm air can be forced out some holes that I'm going to drill in the bottom of the cover. So I'm working on making an actual opening for the vent. Now when you're 3D modeling, it's up to you how detailed you want to get. If it's just for looks, where you just want to capture the exterior look of the product, then you don't have to go through every detail of, every single mounting hole, cutting out the opening like I did for the vent. Depends on your time constraints, your budget, what you're trying to accomplish. And then again, using that extrude command, I did a cut. That's why you see that it turned red, and I removed material to make that flange.
Woo!
And then up there in the design tab, you pull that menu down, and that's where you can go in. You can add color. And the render, got to click on render. So here again, I'm bringing in more parts from McMaster-Carr's website. Get some cap screws to mount this cover to the that center plate, that mounting plate. And I would like 4 of these mounting screws, 1 on each corner. I'm happy with that. And the great thing about that sketch command is you could pretty much draw a sketch on any plane, any face, You can draw hidden lines. So now I'm adding the scrapers where I want them on that mounting plate. The scrapers are going to be what scrapes the oil off the tube as it's pulled through the unit. So you did an extrude feature there, remove material. So that's a top scraper. Need to make a bottom scraper. I'm simply going to make a copy. They're going to be offset from each other. So those two scrapers are what's going to, again, scrape the oil off of the tube as it travels through these rollers. And elongate these shafts and then move the pulleys out because I need to put some gears behind them. Specifically, I need a drive gear on the motor shaft. So I'm going to go to McMaster Car, find the gear I want, bring it in. It's an SAT file. So again, you can see I'm just going to manipulate these parts to get them aligned exactly where I want them to be. Tried a few other gears that I wasn't happy with, so I'm going to stick with these gears that you see here. Just making sure my pulleys stay lined up and my tube scrapers stay lined up with the pulleys. And then I'm going to extend the side of this mounting plate out about 6 inches or so to make room for another large gear. And then there's going to be a tension wheel that's going to push on the tube. So as the motor turns the drive pulley, it's also going to turn the two gears. And that second gear is going to turn the tension wheel, which is going to help keep pressure or tension on the tube so it can be pulled through the unit.
Wow.
I also thought about using one of those adjustable V-blocks where you can make the notch, wider or more narrow. But this seems to work fine. So there's my two gears. I'm going to add a pillow bearing block here on the back. It's got a grease fitting, set screw, because that second gear is going to be able to free spin in the pillow bearing block, but it's going to be driven by the drive gear that's attached to the motor shaft, if that makes sense. So now I'm just doing another sketch, making my tension wheel. I'll extrude it out. I'm going to put a little bit of a bevel on both edges. Then I want a little bit of a collar on it where we can install a set screw. And the set screw will be how it attaches to the shaft. So that gear is going to turn the shaft. At the same time, it'll turn that tension wheel. Just trying to clean up the bore, the inner diameter there. See, I made it too large. So I'm just going to copy that existing set screw and bring it over and place it where I want it. And again, for a 3D model purpose, that's good enough for me. I don't need to make a hole all the way through to the shaft, make a longer set screw and waste time doing that. This illustrates the idea well enough. And then I painted it yellow to make it stand out and obvious what component it is. Now we need to add some mounting bolts for the pillow bearing block. And then I'm going to slot this mounting plate after I get the bolts placed. So that way when you install the tube, you can loosen those mounting bolts And you can see I'm doing my sketch now for the slots and the mounting plate. And that way you can slide that pillow bearing block side to side a little bit to make it easier to install the tube over the pulleys. So you can see we now have some wiggle room side to side.
Woo!
So I'm going to go find the hardware that I want. And I'm going to use T-nuts because they're going to be low profile and they'll fit in those slots nicely. So we'll place the cap screws first. And there's the T-nuts. And I machined off just a tiny bit of material because they were slightly too wide. Just simply use the push-pull feature to do that. And I'm going to rotate it around so it's properly orientated in the slot. And when I'm happy with it, I'll simply make a copy of that one and drag the copy down to meet up with the other cap screw. You can see I still have plenty of clearance for the gears. Nothing's hitting. And I want to make that idler pulley much smaller. So I'm just looking through McMaster-Carr's website here, and I'll bring in a smaller pulley. Because I don't want the tube, when it comes up out of the body of water and that tube is coated with the tramp oil, I don't want it to have a bunch of oil all over that, a bunch of surface area or contact area on that idler pulley. So by using a smaller idler pulley, it'll have less contact area, so more of the oil will stay on the tube and get scraped off on the scrapers. So now it's starting to come together.
Woo!
So that idler pulley, that little red idler pulley, just free spins on the shaft. It's not driven. I'm just repositioning the scrapers to a better location. Yeah, that looks better. Now I'm going to do a sketch and make the drain pan or the triangular shaped trough that's going to catch the oil that is scraped off of the tube. And the drain pan or the drain trough will have a pipe fitting welded to it, and then there would be a hose or a pipe that would extend, to a 5-gallon bucket or a 55-gallon drum, etc., to collect the oil. So here I'm doing my sketch, getting my profile where I want it. You see I'm just simply removing material where I don't want it. And then I'll use the shell command in a minute to make an open cavity. There you go. And there's your drain trough. Now I'll make a hole in the bottom on the back side. And that will be where we weld our 90-degree pipe elbow in place. And again, I don't have to draw the elbow. I can simply go to McMaster-Carr's website and bring one in to my 3D model, saving time. I'm going to do a reducer elbow. So we're going from 1.5 to 1 inch. So now I'm doing a sketch on the bottom of the motor cover, or housing, if you will. And I did a pattern of holes, and now I'm going to remove material, essentially drill out material, and there you go. That's the exhaust vent on the bottom of the motor cover. So we can keep that motor cool. Now I'm adding a strain relief for the power cord. Of course, a weatherproof strain relief. And then we'll add a toggle switch, on and off toggle switch. It's a 120 volt AC circuit. Again, this is a weatherproof toggle switch. Just placing it where I want it, rendering it. There you go. And again, saving as I go along. I'm pretty happy with that. So the next couple steps on this project, we need to make a cover to go over all the pulleys. Keep the rainwater and dust and dirt out and hands out of there. So again, make a sketch on the base plate, make a new body. It's a rectangular body, as you see. Making sure we have adequate clearance for all of our components inside there. We do. And the bottom's going to stay open, of course, because we have to allow the tube to go up inside and then exit. And so I'm just making do the shell command, doing a drawing to make the mounting flange. So this cover is going to bolt to that center mounting plate. Paint it blue. And again, I'm just going to copy the existing cap screws. And do that in all four corners. And there's your cover.
Woo!
I'm pretty happy with that. So next, I want to put a safety decal on the front of this cover to warn people, don't stick your hands in there. It's a hazard, a crush hazard. So I'm going to simply add a decal. And you can manipulate the decal, rotate it around, adjust the opacity, and place it where you want it. And there's your sticker or your decal. And then we'll also show you how to add text, embossed text in this case. So I'll make an embossed label using the text command. And it's going to say oil skimmer, just to give you an example here in a minute or two. So you can see there's text. You click and drag and essentially make a little rectangle. Type the text that you want it to say. And make it bold. And then when you're happy with it, hit OK. And then over my browser, I'm going to select each and every letter in my browser. And then I'm going to pull them out. I'm going to extrude those letters out by about 1/8 of an inch. And there you go. You can see those letters are three-dimensional now.
Wow.
They stick out from the surface. And then we'll go back into render, and I'll change the color of those letters as well. So now we're going to render them, turn them yellow. Just drag and drop the color. And then back into design mode. The next step, we need to weld some square tubing, 1.5 inch square tubing, to make legs and a mounting plate so you can bolt this to the concrete. So again, I do another sketch on the surface. So now I'm getting ready to make my 1.5 inch square tubing. I make one, and then I simply copy it to make the second one. So now I got my two legs. There you go. And on the bottom there, I'll make a sketch on the bottom of one of those legs and make our mounting plate or base plate where it'll bolt to the concrete. And then we'll add some mounting holes as well for some 3/8 concrete anchors. And then we'll paint it blue. So again, I'm doing another sketch now on the top side of the mounting plate. And just working out where I want to position my mounting holes. And I'm also making some triangular shaped gussets to add extra support and rigidity to those square tube legs. And I'll just simply copy that gusset and move the second copy over to the other leg, and there's your gussets. And paint those in the render. You can see I need to move that base plate over. It's slightly offset. So I'm going to move the base plate over, and I'm also going to get my holes made in this plate. So again, you can see it's still in sketch mode there when you see the grid lines. There, I'm moving the plate over. Now it's centered. So now I'm going to edit my sketch. Yeah, see we're in sketch mode. You can see the light gray grid lines. That's how you can tell you're in sketch mode. And so we'll add our 4 mounting holes, 3/8 diameter. And then the same thing, we'll go back to design mode. We'll extrude the holes out and then remove material. We're actually cutting out material. So if you pull the arrow one way, it adds material. You pull the arrow the other way, it removes material. Yeah, that looks good. I'm happy with that. So now I'm creating a plane, an offset plane that's aligned with my pulleys. And on that offset plane, I'm going to do a sketch. And I'm simply going to make some lines and some arcs to trace out the path of where I want the rubber tube or the acrylic tube to go through the pulleys and through the scrapers. And then we'll use the pipe command to make a half-inch flexible tubing. So you can see I'm just routing it around in sketch mode. And get the idea. Just make sure all your line points connect. And then I'm going to remove, see there's a circle there, I'm going to remove some of that. Because I just want the arc, I don't want the whole circle. I'm going to manipulate that point so it lines up with that scraper. Yep. And there it is. Then go to create. Click on pipe. And then click on each line segment. And it automatically starts to create a pipe, follows your line. I'm going to set the size to 1/2 inch, make it hollow, tell it 1/8 inch thick wall. And there's our tubing. Then I'll go into render, and I'm going to select material that's translucent or transparent to more accurately reflect tubing. So again, just start with the lines and then the pipe when you make the pipe, it's going to follow those lines you add. If that makes sense. Again, back to the pipe command, do it again. You see how that works. Set the size or the diameter. Hit OK. And then in render, you can go through, you see you got different materials, and different materials will have different textures. To mimic that real life look of some flexible translucent tubing. And there we go. And I want to extend the tubing down a little bit more just for good measure to make it clear. I'm just manipulating the scrapers so they scrape the top and bottom of the tubes properly. Right about there. Looks good. Yeah, I'm happy with that. So then I just click on that bottom face right there, and then I'll extrude it down to make it longer. I'll do the same thing on the other side. There's a cover. Everything looks good. I'm happy with that. And there's our oil skimmer.
Woo!
So I hope this demonstration helps. Please like, share, subscribe, and leave me a comment. Thanks for watching.